sitting here in front of this camera alone because my whole group decided to quit on me and I didn't give up on this project. I need the extra credit and I don't know. I thought it would be fun. I thought. But sitting in front of a camera alone and trying to gather up the guts to spend at least 6 minutes talking about batteries, which, let's face it, nobody really wants to hear that much about batteries. But I figured I would make it at home in a vlog type setting because that's something that I'm comfortable with. So, hi, I'm Stevie, and I'm here to talk to you about batteries. And not just basically about batteries, but I want to talk about how we can change the way we consume batteries to help the environment and to help energy efficiency. I'm going to help energy efficiency. You know what? I'm not even going to worry about my word choice at this point. To be more efficient with our energy. There. I fixed myself. Okay, so if you kind of missed a rung on the generational ladder and don't know what a battery is, a battery is one or more electrochemical cells that convert stored chemical energy into electrical energy. If you don't know what that means, basically it's chemicals being converted into energy to power your electronics, basically. Since the invention of the first battery by Alessandro Volta in 1800, which is called the voltaic pile, and especially since the Daniell cell in 1836, batteries became like a common power source for a lot of household applications, and industrial too. There's an estimate in 2005 that stated the worldwide battery industry generates $48 billion in sales every year, with 6% annual growth. So batteries are kind of a big deal. I mean, we use them in everything. I mean, there's batteries in our cell phones, batteries in my laptop that I can't show you because I'm recording with it, batteries in wireless mouse, batteries in literally everything. There's batteries in your car, there's batteries in satellites, I think. Yeah, they have to run on something. There's literally batteries in almost, well, okay, not almost, in like every electronic device, every handheld device. Your phone wouldn't work without a battery. Your iPod, we don't use Walkman anymore unless you're me because I'm old school, but batteries are really important. But they also cause a huge problem, which I'll get to later. For now, I just want to give you a bit of an intro on what batteries are all about, the different types, and yada yada yada. So let me start with saying that there are two main types of batteries: primary batteries and secondary batteries. Primary batteries you would probably know more as disposable batteries. You know, the ones you use once and throw away. And then secondary batteries are rechargeable batteries, which you recharge and use multiple times, like your cell phone battery or your computer battery. And they come in tons of sizes, from mini cells to power hearing aids and watches, to battery banks the size of rooms that provide power for telephone exchanges and computer networking centers, and all of these things. I actually have drawn up the symbol for a battery in a circuit diagram that is based on the schematic drawing for the voltaic pile, which was the original battery. So that is how a battery would be shown on a circuit diagram, which is drawn when a circuit is made to show how the energy flows through it. So basically, a battery converts chemical energy to electrical energy, and it consists of a number of voltaic cells. And here is a basic sketch of a voltaic cell. I won't go into huge detail about how it works because everyone in AP Chem should know that. So, okay, let's talk about primary batteries for a minute. Your basic disposable batteries, you know, the ones in your calculator that after they die, you throw them out. They are intended to be used once and discarded, which is obvious. They produce current immediately on assembly. They're most commonly used in portable devices that have low current drain, or are only used intermittently, or are used well away from alternative power source, like alarm and communication circuits where other electric power is not always available. They can't be reliably recharged since the chemical reactions aren't reversible, and the active materials may not return to their original forms. So battery manufacturers recommend against attempting to recharge primary cells. It's a bad idea, kids. Don't do it. Some common types are zinc-carbon batteries and alkaline batteries. They have higher energy densities than rechargeable batteries, but disposable batteries don't fare well under high drain applications. So you can't really they don't really give you a lot of energy. Secondary batteries, rechargeable batteries, have to be charged before use. They're usually assembled with the active materials in a discharged state, so that so that the reaction isn't taking place before you charge the battery. They are recharged by applying an electric current, which basically means plugging it in, which reverses the chemical reactions that occur during the use. The oldest form of rechargeable battery is the lead-acid battery. This battery contains liquid in an unsealed container, so the battery has to be kept upright and the area has to be well ventilated because it produces hydrogen gas. The lead-acid battery is also very heavy for the amount of energy it can supply, but despite this, it has a really low cost and high surge current levels, so its use is pretty common where a large capacity is required or where the weight and ease of handling aren't really concerns. A common form of lead-acid battery is the car battery, which can in general deliver a current of 450 amperes. An improved type of liquid electrolyte battery is the sealed valve regulated lead-acid battery, or the VRLA battery, which is popular in the automotive industry as a replacement for the lead-acid wet cell. It uses an immobilized sulfuric acid electrolyte, which reduces the chance of leakage and extends shelf life. The electrolyte is usually immobilized either by a gel battery, which contains a semi-solid electrolyte to prevent spillage, or you have absorbed glass batteries, which absorb the electrolyte in fiberglass matting, so that you obviously don't have leakage, because you definitely don't want that. Other portable rechargeable batteries include a few dry cell types, which are sealed units and really useful in things like cell phones and laptops. Some examples are nickel cadmium, nickel zinc, nickel metal hydride, and lithium ion. And lithium ion has the highest share of the dry cell rechargeable market. Meanwhile, nickel metal hydride, NiMH, has replaced NiCads in most applications because it has a higher capacity, but NiCad is used in power tools, two-way radios, and a lot of medical equipment. And then nickel zinc is a new technology that was just developed in 2009, and it's not really well established commercially yet. There's also been a recent development with batteries that have embedded electronics, like a USB cell, which allows you to charge a AA battery through a USB connector. And then we have smart battery packs with state-of-charge monitors and battery protection circuits to prevent damage on over-discharge. And then we have low self-discharge, which allows secondary cells to be pre-charged prior to shipping. Alright, before I get to my point, I'm going to give you a pitch about what batteries I think should be used in a more widespread manner to help the environment. But before I do that, you need to know about battery hazards. One of the biggest hazards, well, not the biggest hazards, but one of the most terrifying hazards is explosions. A battery explosion can be caused by the misuse or malfunction of a battery, like attempting to recharge a primary battery or short-circuiting. Car batteries are most likely to explode when it's short-circuiting, because they liberate hydrogen, which is extremely explosive when they're overcharged. The amount of overcharging is usually really small and generates a very small amount of hydrogen, which kind of goes away really quickly. But when you jump a car battery, the high current can cause the rapid release of huge amounts of hydrogen, which can be ignited by a nearby spark, for example, when you disconnect the jumper cable. So when a battery is recharged at an excessive rate, an explosive gas mixture of hydrogen and oxygen is produced faster than it can escape from within the walls of the battery, which leads to a pressure buildup and the possibility of bursting of battery case. In extreme cases, the battery acid may spray violently from the casing and can cause serious injury. Overcharging, which is charging a battery beyond its electrical capacity, can also lead to a battery explosion, in addition to leakage and other irreversible damage. It can also cause damage to the charger or the device in which the battery is used. Also, disposing of a battery in fire may cause an explosion because steam will build up within the sealed case. Another serious issue is leakage. Many chemicals in batteries are corrosive, poisonous, or both. So if leakage occurs either spontaneously or by accident, the chemicals released can be really, really dangerous. For example, disposable batteries often use a zinc can as a reactant and as the container to hold the other reagents. So if this battery is run all the way down, or if it's recharged after running down too far, the reagents can emerge through the cardboard and plastic that form the rest of the container. The active chemical leakage can then damage the equipment the batteries were inserted to. For this reason, a lot of electronic device manufacturers recommend removing the batteries from a device that won't be used for a long period of time. You know how you leave... Alright, everybody's got flashlights in the house. You know how you just kind of leave them in a drawer until you need them? Bad idea, kids. Alright. And then ingestion is an issue because small button cell batteries can be swallowed by young children, or by anyone in fact, but mostly small children, because I don't envision an adult knowingly swallowing a battery. Or unknowingly. I mean, it'd be kind of a hard thing to slip into someone's drink. But while it's in the cannot talk, I apologize. While in the digestive tract, the battery's electrical discharge can lead to tissue damage. And it's occasionally serious and rarely leads to death. It doesn't usually cause problems unless they become lodged in the gastrointestinal tract. The most common place disc batteries become lodged is the esophagus. The likelihood that it'll lodge in the esophagus it depends on the age and the size of the battery. So there's not really a lot of issues with ingesting batteries, but it's still kind of dangerous. Okay, so to talk about some environmental concerns, because that's really what my whole point of this project is. There's a lot of issues with toxic metal pollution. Battery manufacture consumes a lot of resources, and often those resources involve hazardous chemicals. Used batteries also contribute to electronic waste. Some areas have battery recycling services to recover some of the materials from used batteries. And there is recycling or proper disposal that can prevent dangerous elements like lead, mercury, and cadmium from entering the environment. Basically, Americans purchase nearly 3 billion batteries every year, and about 179,000 tons of those end up in landfills across the country. The Mercury-Containing and Rechargeable Battery Management Act of '96 banned the sale of mercury-containing batteries and required that rechargeable batteries be easily removable. California and New York City prohibit the disposal of rechargeable batteries in solid waste, and along with Maine, require recycling of cell phones. And the rechargeable battery industry's nationwide recycling programs in the US and Canada, with drop-off points at local retailers. And the Battery Directive of the European Union has similar requirements, in addition to requiring increased recycling of batteries and promoting research on improved battery recycling methods. In accordance with this directive, all batteries to be sold within the EU must be marked with the collection symbol. This has to cover at least 3% of the surface of prismatic batteries and 1.5% of the surface of cylindrical batteries, and all packaging has to be marked the same way. In the US, we don't have anything that extensive yet, and while we do have recycling programs, it's not very easy to find a place to recycle your batteries or used electronics, so people end up doing the easiest thing and just throwing them in the trash. personally think that we should stop using primary batteries at all, because there's not a lot of ways to recycle them that are well known to the public. And all of them have a voltage range between 1.5 and 1.7, which isn't very high, so you don't get a lot of energy out of them. They don't really last a very long amount of time. So, if we can replace all primary batteries with secondary batteries that can be recharged and used for longer periods of time and have less hazardous materials, then we can do the entire planet a favor. Secondary batteries have a voltage range from 1.2 to 3.6. The highest 3.6 being a lithium-ion battery, and the lowest being NiCads and NiMH. NiCads are very inexpensive. They can withstand really high discharge rates with no loss of capacity. But they're reputed to suffer from memory effect, which means that they tend to have early failure, and they're environmentally hazardous because of cadmium. They're basically prohibited in Europe at this point. With a voltage of 2.1, we have lead-acid batteries, which are moderately expensive. They have a moderate rate of self-discharge, and at higher discharge rates, they have a considerable loss of capacity. It doesn't suffer from memory effect, but it has environmental hazard due to lead. NiMH batteries are pretty much inexpensive. They perform better than alkaline batteries in high drain devices. Nickel zinc batteries with a voltage of 1.6, they're moderately inexpensive, low self-discharge rate, high drain device. Well, they're suitable for high drain devices. They have no toxic components at all, but they're newly introduced to the market, so they don't really have a track record yet. So nobody really knows exactly how well they work, and they're only available in limited sizes. And then with our 3.6, we have the lithium-ion batteries. They're very expensive to make, but they last for a very long amount of time. They're not usually available in common battery sizes, but they're really common in laptop computers, digital cameras, camcorders, cell phones. They have a very low rate of self-discharge, which means that they'll work for a really long period of time. But they are volatile. There's a chance of explosion if short-circuited or allowed to overheat, which is true for any battery, but more so with lithium-ion batteries. But despite this, I think that lithium-ion batteries are probably one of the best batteries that you can use. Though they are expensive, they do last for a very long amount of time, and you get a lot of energy out of them. And because they're rechargeable, you don't have to worry about recycling them. Well, you do, but after years and years and years and years and years. And they're not leaking toxic chemicals into the environment, which is definitely a plus. And then there is the new nickel zinc battery, which, though it doesn't have a good track record yet, there's a chance that it will. And while it doesn't have a very high voltage, it'll work about the same as an alkaline battery will. It'll just be rechargeable. So it'll work just like the AA batteries in whatever uses AA batteries now. I don't even know. It'll work just like the batteries in your calculator or the batteries in your camera, but it'll be rechargeable. And there are absolutely no toxic elements, which is great. A little bit about I actually have an article up, 5 reasons to use rechargeable batteries, that I wanted to share because I think it's pretty important. This article is about Uniros, which is a European leader in rechargeable batteries. They did the world's first independent study that compares the environmental impact of disposable and rechargeable batteries. And the study shows that for the same quantity of energy produced, rechargeable batteries have up to 32 times less impact on the environment than disposable batteries. Peter Keene, a representative of Uniros, says that no study has ever shown the environmental benefits of rechargeable batteries. Today, when the choices of responsible consumption are at the heart of the debate, the Uniross study proves that switching from disposable to sustainable is not only possible but also necessary. In the UK, 660 million batteries are bought each year, and 95% of them are disposable. That's a huge amount of batteries going right to landfills and releasing really damaging chemicals in the environment. It's wasteful and it's unnecessary. Rechargeable batteries are a really easy environmental, thumbs up. They have 28 times less potential impact on climate change than disposable batteries. Using them won't reduce your standard of living, and it'll hugely reduce your impact on the planet. Rechargeable batteries consume up to 23 times less non-renewable natural resources than disposable batteries, which is explained by the much higher number of disposable batteries that have to be produced to provide the same amount of energy. Climate change means an increase in the average temperature of the Earth's surface caused by an increase in the greenhouse gas effect. Rechargeable batteries have up to 28 times less impact on climate warming than disposable batteries, which is basically explained by the impact caused when manufacturing disposable batteries and distributing them, because they're, the transportation in trucks and the related greenhouse gas emissions. Because more disposable batteries have to be created to equal the same amount of energy that a rechargeable battery can use, more of them have to be transported and more often. Photochemical oxidation is responsible for peaks of ozone and toxic emissions. Rechargeable batteries have up to 30 times less impact on ozone pollution than disposable batteries. Rechargeable batteries have up to 9 times less impact on air acidification than disposable batteries because, the sedimentary ecotoxicity indicator evaluates potential toxic risks due to emission of chemicals into aquatic ecosystems. And for a given quantity of available energy, rechargeable batteries have up to 12 times less toxic risk for freshwater and seawater sediments than disposable. The study also drew up a list of raw materials used for each type of battery, taking into account all of the materials used. Using rechargeable batteries provides real savings on packaging waste, since one pack of rechargeable batteries is needed to obtain 1 kilowatt of energy, compared with 93 packs of disposable batteries. And it also provides a way of reducing the amount of batteries that end up in landfill. Each year, around 660 million of household batteries sold in the UK, 99% ends up in landfill. The average household uses about 21 batteries a year. Changing to recharging batteries is not only greener for all of those reasons, but it's also cost effective. You end up having to buy less batteries. I mean, we all know that batteries don't last forever. And when the flashlight dims, you're basically left with a huge handful of toxic heavy metals to get rid of. Americans buy about 4 billion batteries a year, and we throw out about 2.5 billion of them. Household batteries actually make up a really small portion of the waste stream, but they're a significant source of contaminants. More than 80% of the mercury in the waste stream is traced to discarded batteries. When you bury a battery in a landfill, the casing eventually corrodes, and heavy metals leach into groundwater. Burning batteries is no better because if they're incinerated, the toxics are released into the atmosphere, and the incinerator ash becomes contaminated and harder to dispose of safely. So basically, the best thing that we can do for the environment is to use rechargeable batteries. And preferably those batteries with no toxic elements. And nickel metal, don't remember what it's called, NIMH batteries are very inexpensive, and so are nickel zinc batteries. They're moderately inexpensive, and they work well. Not with an extremely high voltage, but they're affordable and just will do so much to help the environment. And of course we have our lithium-ion batteries that, I recommend. I'm in love with Li-ions. I would marry a lithium-ion battery. But that's just because I like a lot of energy in my man. That was creepy. I'm gonna cut that out. Yeah, I'm gonna edit that out. And if I forget to, then everyone can laugh at me, because I don't think I know how to use Windows Movie Maker. Anyway, that's basically the gist of what I want to say, and I really, really hope that I didn't completely demolish this, because I had to do it on my own, last minute. I thought I was going to have a group behind me. I have neither the materials nor the time to do the lab experiment that I wanted to do. I wanted to make a lithium-ion battery and compare the voltage to just a regular old battery, preferably a disposable one. But I didn't have the chance to, so I had to settle for comparing voltages that I found online. So here I am, advocating protecting the environment by not being insufferable pricks and using rechargeable, non-environmentally harming batteries. That's basically all there is to the matter. And there's nothing harmful to the environment about lithium or nickel or zinc or any of the chemicals that are used in any of the batteries that I've recommended today. So give it a shot. Go out and buy rechargeable double and AAA batteries. I know Kodak sells them because I buy them. So go out and use those instead of continuing to buy a 20-pack of Duracells for $20 every time that you need new batteries. You'll do yourself a favor, you'll do your wallets a favor, and you'll do the environment a favor, because nobody likes heavy metal. Well, the toxic kind, nobody likes. Not discriminating on your music tastes. But that's all for now. So, ciao.